Hello guys, welcome back to the Quantities Surveying workshop and to another video. In today's video, in the measurement for roof members, that's a hip roof, we are going to be treating how to measure for the struts in the roof. As you all know, the struts are the members that give bracing to the trusses. If you look at this drawing, basically these members are the struts, so we are going to be calculating for them. So when measuring for these struts, it would usually be designed by the engineer. So this is just a rough drawing. So we're going to be assuming that there are 3 struts after the king post. So that's 1, 2, 3. So the members we're going to be looking for are this, and then the bracing, that's this, and this. You know that this is our king post, and they've already given us the height of our king post as 3.50. So we're going to be looking for the bracing. So how do we do that now? You know that this is a triangle. If we divide the triangle by the king post here, we have a right angle triangle. So what we are going to be doing now is that we're going to be bringing out the right angle triangle. That is the triangle consisting from the king post down to the tie beam. So the rafter does not prolong down here. We are going to be cutting the rafter as it stops or hits the tie beam. So that is the triangle we're going to be cutting out, as I did over here. So since we've gotten our triangle, now it's stated that the triangle now, the triangle here has how many struts? As I said before, 3 struts. This is the king post, the first strut, second strut, and the third strut. Then you are going to put the bracing for each. That's this, and this, depending on the design. This is the design we got, so this is what we are going to be calculating for. So we are going to be looking for A, B, C, D, E, F. All of them are called struts, that's bracing. So now, doing this, you have to be conversant with trigonometric rules and trigonometric ratios. So trigonometric rules in the sense alternating angles, corresponding angles, angles in a straight line, and stuff like that. So before we get there, we know that this member from here to here is half of our tie beam. So when we divide our tie beam into 2, we have 5,362.5. We are going to be dividing this half tie beam into 4 places. That's 1, 2, 3, 4. That's to accommodate the 3 members, because these 3 members will be dividing this straight line into 4 places. So when we divide it into 4, we are going to be having 1,340.63 on each side. So we have 1,340.63 here. We're going to be having the same thing from here to here, the same thing from here to here, the same thing from here to here. Now we've gotten the distance from here to here. We are going to be finding the angles of each triangle. You know that we divided this big triangle into smaller triangles. So now we have to find for the angles of each side. And how did I do that? We're going to be starting with the known points first. This part here is our pitch angle, and in the drawing it is given as 30 degrees. So we're going to be writing it, because this is the most obvious one, 30 degrees here. That is what I did here, 30 degrees. This is an angle 90, but it has been divided into 2. That's an angle here and an angle here. This is angle 90 from a right angle triangle, so you put it down, right angle triangle. This is also a right angle triangle, you put it down. the right angle triangle, put it down. And also here, if you mirror it, the right angle triangle here, you put it down. So now that we have 30, whatever we have here would be what? 90 degrees. If 30 plus 90 plus x would give me what? 180 degrees. That's sum of angles in the triangle is equal to 180. So if angle 30 plus 90 plus x is equal to 180 degrees, therefore what is x? If you add 90 plus 30, that will give you what? 120. 180 minus 120 will give you what? 60. That means this angle here is what? 60 degrees. So we have gotten for this angle, and what? Here as 90, but we still need to look for each. This angle here, we need to look for what this one and this one is. How did we get it? So before we get there, we've gotten 30 and we've gotten 60. If here is 60, it means that this angle here is corresponding to this angle here, and it is also corresponding to this angle here, and it's also corresponding to this angle here. So it means that if here is 60, here will be 60, here will be 60, and here will be 60 also. Since we've gotten that, we know that this triangle here is the same thing as this triangle here, so we will mirror it. If here is 60 degrees, it means that here also will be 60 degrees. So now we've gotten for 30, we've gotten 60, we've gotten 90. The second triangle, we've gotten 90, we've gotten 30, we've gotten 60, because what we have here is the same thing as what we have here. So since we've had 60, 60, we want to find for x, that is this one here. So what would I do? This is an angle at a straight line, and angle of a straight line is equal to what? 180 degrees. So 60 plus 60 will give me what? 120. 180 minus 120 will give me what? 60. So it means that if here is 60, here is 60, and here is 60, adding everything together will give me angle at a what? Straight line, which is what? 180. So now we've gotten here as 60. So it means that this angle here corresponds to this angle here, and it also corresponds to what? This angle here. Meaning, since we've gotten this, this, and this, we need to find for the middle here, the angle at this middle. You still do the same thing. Angle on a straight line, which is 180. We have 60, we have 60. We are saying that this is the unknown. So 60 plus 60 is 120. 180 minus 120 will give me what? 60. That is how we got this 60 here. So we found for this whole side like this. The next one we're going to be looking for is this side. You still do the same thing. This angle here corresponds to this angle here. So if this is 60, this also is 60. We say that this angle corresponds to this angle, so this is 60. 60 plus 60, 120. This is unknown, this is x. So 60 plus 60 plus x will give me 120x is equal to what? 180. Then you minus 120 from 180 to find your what? X, and that will give me what? 60. So therefore here is 60. Here is 60. So if this angle here is 30, it corresponds to this angle here, which is what? 30, and it also corresponds to this angle, which is what? 30. So I found here as what? 30 degrees. Now we know that from here to this angle here is a 90 degrees, and we know that this angle here is 30 degrees. So how do we find this angle here? What can we do? We will say what? 30 plus x is equal to what? 90 degrees. How do we find x? 90 minus 30 will give you what? 60. So here is what? 60 degrees. Doing this, we found for all the angles for each triangle in this strut. Now, if you are able to do this correctly, then finding the the measurement of each of the struts shouldn't be difficult. So how do I do that now? We're going to be bringing out importance triangles and finding A, B, C, D, E, and what? F. So now I am looking for A and B. To find A and B, we are going to be bringing out a triangle that composes or that has both A and B, which is this triangle here. So I will bring this triangle out. That is what I put as triangle 1. So I will define it. This is the triangle. We know that from here to here, that's 1340.63 is the same thing as this, this, and this. So here to here would also be this. That is how I got 1340.63. So we define the triangle now. A, B. Here is 60 degrees. Here is what? 30 degrees. Now we are looking for A. So we can use what? SOHCAHTOA. That is sine, cos, and what? Tangent. So since we are looking for A is the unknown. We have this known. So it is tangent we are going to be using here. So tan 30 degrees is equal to what? A all over what? 1340.63. A is the opposite, and the adjacent is what? 1340.63. So to find A, we cross multiply. A is equal to what? 1340.63 times what? Tan 30. Therefore A is equal to what? 774.01 meters. That is here. There's this A here is equal to what? 774.01 meters. So in order to find B, you use the Pythagoras theorem. Since you know that the Pythagoras theorem is the hypotenuse square is equal to the sum of the square of the two other sides. So the hypotenuse is our B. So we'll now write B square is equal to what? A square. We found our A at 774.01. That is what I brought down here. Then plus the other side, which is 1340.63 square. B square is equal to, you do the operation for this in your calculator, and that will give me 2,396,380.277. B will now be equals to what? The square root of what? This. So square root will cancel the square, leaving only B. Therefore B will now be equals to what? 1548.02 meters. Now we've gotten for what? A, and we've gotten for B. So the next triangle we're going to be taking to find our C would be this triangle here. So I want you to watch my hand to see how I'm taking the triangle. This triangle. So that is what I am going to be cutting out, and that is what I did here. How did we get the distance for this triangle here? If you look at this, from here to here is 1340.63. From here also to here is the same thing. So you just times this one by 2. It will give you from here to here. And that is how we got 2681.26, which is this. So now we're looking for what? C. Then we define the triangle 30 degrees, 60 degrees. So how do we find for C? You do the same thing, your SOHCAHTOA. We have our what? Opposites, and we have our adjacent. So we're going to be using what? Tangent. So tan 30 degrees is equal to what? The opposite, which is C, all over the adjacent, which is what? 2681.26. C will now be equal to what? You cross multiply. That's 2681.26 times what? Tan 30. C will now be equal to what? 1548.03 meters. Doing this, you've gotten for C. So I've gotten for A, B, C. The next thing is what? D. Now if you look at where D is positioned. How can we look for D? We can bring out this triangle here in order to determine what D is. And this triangle, we can define it by saying we need the distance from here to this side, which is what? 1340.63. Then we also need the value for C. So the value for C we've calculated as what? 1548.03. And then we've gotten the value for the adjacent side, which is 1340.63. So in order to find for D, all we need to do now is to use the Pythagoras theorem. So D square is equals to what? 1548.03 square plus what? 1340.63 square. And that will give me what? 4,193,685.68. So you what? Square root. The D will now be equals to what? 2047.85 watts meters. And that is how we got our what? D. So now, to find E, what can we do? This is our E. So we'll take this whole triangle here. This whole triangle here to find our what? E. And that is what I have brought here. So this is E. We need to find from here to here. So to find from here to here, all you need to do is this: 1340.63 times what? 1, 2, 3. That's times 3, because here, here, and here are what? Equal. And that is how we got what? 4021.89. So now that we have our adjacent, our opposite is what? E. We will use what? Tangent. So tan 30 degrees is equal to what? Opposite over what? Adjacent. That's E over 4021.89. So E will now become what? When you cross multiply, 4021.89 times what? Tan 30 degrees. E will now be equals to what? 2322.04 meters. So now that we have gotten our E, we can now get our F, because if you look at this triangle here, this triangle comprises of E and F. We found our E, which is 2322.04 meters, and now we need to find our F. So the F is the hypotenuse, the E is the opposite. We know our what? Adjacent, which is 1340.63. That's from here to here. So we can now define the triangle. Here the adjacent 1340.63, the opposite 2322.04, which is E. Then we can now find our hypotenuse F. So we use the same thing, Pythagoras theorem. F square will now be equal to what? 2322.04 square plus what? 1340.63 square. So when you do the operation, it will give you 7,189,158.56. So you square root it. So F will now be equal to what? 2,681.26 meters. So doing that, you've gotten for what? All the struts in this triangle. So after calculating everything, I did a summary here of everything we've calculated. So we've calculated for A, which is this, B, which is this, C, which is this, D, which is this, E, this, and what? F, which is equal to what? This. So we are going to be what? Describing. So our specification says that the hardwood we are going to be using is 50 by what? 150 mm. So we will now describe 50 by 150 mm sun hardwood struts to brace roof what? Truss. So now we're going to booking. So the first thing we're going to be booking is what? A, which is what? 774.01. Convert it to meters. That's how we got 0.77. Now, why did we multiply it by 2? We multiplied it by 2 because the struts we have at this half of the triangle is the same thing we're going to be having at this half of the triangle. So whatever we're having here, we're going to be having here. So we times it by what? 2. So after timesing it by 2, I times it by the number of trusses we have, because each truss is going to be braced by a what? Strut. You know, in the beginning of the video, we calculated the number of trusses we are going to be having in the roof as what? 3. So that is why we multiplied it by what? 3. So after booking for A, we'll book for B, multiply it by 2, times it by the number of trusses. The next one is C, multiplied by 2 by the number of trusses. D, multiplied by 2 by the number of trusses. E, multiplied by 2 by the number of trusses. And you do the same thing for what? F. Now after doing this, you now get the value of what you've done here. That 0.77 times 2 times 3 will give you this. So when you do it for everything here, these are the values. You write it in your what? Squaring column. Then you sum everything together, which will give you what? 65.52. So this is the total amount of 50 by 150 hardwood you are going to be using for your what? Struts. Now doing that, you've calculated for your what? Struts. The next thing we're going to be calculating for are your purlines. The purlines are these little members on top the rafters that are going across the rafters that will now what? Carry the roofing sheets. So we need to calculate for what? Each of them. So we said that in our specification, the purlines, which is this, are at what? 900 center to what? Center. So we are going to be using that to determine the number of purlines we have in the roof. So in order to determine the number of purlines we have in the roof, what you will do, go and get the measurements of your principal rafter or your hip rafter, and we calculated that measurement as what? 6,884.93. That was the measurement we calculated for our principal rafters. So principal rafter is 6,884.193. You divide it by what? 900, and that will give me what? 7.6. So that's approximately 8. Then you write what? Plus 1, which is equal to what? 9. So we're going to be having 9 number of purlines. So to find for the length of our purlines, we are going to be assuming that all the purlines are equals to the length of the roof span. Now if you look at this drawing, you know that it is not a gabled roof. This drawing or this roof is like this. So it means that the purline here would not be equals to the purline here, would not be equals to the purline here, and will not be equals to the length of the purline here, because it is sloping. But we have to assume that every of the purline here is what? The length of what? The roof. And what is the length of the roof? So if you look at this drawing, the length of the roof is what? 14,025, while the width of the roof is what? 11,925. So the purlines for this length would be what? 14,025, while the purlines for this side would be what? 11,925. So we will what? Describe in our specification. They say that the purlines are what? 50 by what? 75. So we write 50 by 75 sun hardwood purline supported by roof what? Rafters, because they are going to be what? Nailed to the what? Rafters. Then you book for the length side. We said that the length is 14,025. When you convert it to meters, you get 14.03. that's 2 decimal places. Then for the width side, we have 11,925. When you convert it to meters, that's 11.93 in 2 decimal places. Now, how many purlines did we calculate in the beginning? We got 9 numbers, so you times it by what? 9, and you times it by what? 2, because the length side would be on what? 2 sides. What I mean is this: the purlines we have here is the same thing as the purline we have here. The purlines we have at the triangle side is the purlines we will have at the triangle side. That's why we multiplied each by what? 2. So that's 14.03 times 9 times what? 2. Then this, the width side, 11.93 times what? 9 times what? 2. So when you find the value, you put it in your what? Square column. That is 252.54 in meters, and what the width side is 214.74 in meters. Add everything together, is to give you what? 467.28. So this is the number or the value of purlines that you are going to be using for this roof. So after doing this, you are going to be measuring for what? Your fascia board. Now, if you look at this drawing, where is your fascia board? This wood here covering the side of the roof is what you call your fascia board. Sometimes they don't use fascia board, maybe when it comes to more sophisticated buildings. Sometimes when it comes to more sophisticated buildings, you might begin to see parapets. Now, for this plan or for this drawing, we are going to be using a fascia board, and this is what the fascia board. These pieces of plank or wood that they use to line the entire sides of the roof. So we are going to be measuring for it. How do we measure for it? This fascia board is going to be lined round the entire side of the roof. So how do we measure for the fascia board? All we need to do now is to determine the perimeter of the roof. So we know that the length of our roof is this, 14,025, and the width of our roof is this, 11,925. So the fascia board is going to go like this. Do you understand? It's going to go around the perimeter of this roof plan. So you find for the perimeter of the roof, we know that our length is 14,025. The width is 11,925. So when you add it together, you get what? So you get 25,940. Then you multiply it by what? 2, and to give you what? 51,900. So this is the perimeter that we are going to be having the what? Fascia board. So we will describe 300 by what? 3,600 mm wrought hardwood. So it means that the span of each of the wood we are going to be using for this fascia board is what? 3,600, and then the width is what? 300 mm. So wrought hardwood fascia board painted with 2 coats of what? KPS paint. So then you describe, put on the what? Perimeter, 51.90. Doing this, you've measured for your what? Fascia board. Then the next thing we're going to be measuring for are the eaves board. Now, what are the eaves board? The eaves board is that piece of wood that is lined underneath the fascia board or underneath the eaves projection. So you know that from here to here is your eaves projection. So we need to be closing it so that we'll not be seeing this roof member as the rafters inside. So we're going to be closing it with wood. So now this eaves board is going to round throughout what? The eaves projection. I know that the eaves projection lines around the building. So how do we find this? Now if you look at this drawing, the piece of wood lining in between this dotted line and the thick line that's here, like the distance between these two arrows, is what? Your eaves board. So the wood is going to line throughout that space. Now, how do we find for the measurement of this eaves board? What you are going to be doing is to find for the center line of this space, that's from between here and here, that's this space here, the middle. Find for the center line round that perimeter. So how do we find for the center line now? We know that the perimeter of the building, of the roof rather, the perimeter of the roof, like we calculated on the fascia board, that's when you find the perimeter from this the length, this the width. We calculate the perimeter here as what? 51,900. So I didn't want to waste time recalculating it. So see, the center line is 51,900. Then we're going to be lessing what? 2 by 4 by half of what? 600, which is the what? Eaves projection. The eaves projection is what? 600, and that will give me what? 2,400. So we're going to be lessing 2,400 from what? 51,900. Why are we lessing? This is the perimeter for the out-to-out dimension of the what? Roof. So when we less this from this, we're going to be getting what? 49,500. So this is the what? Perimeter of the center line of the eaves board. So when you get this, all you need to do now is what? Describe. So we'll describe 75 by 20 mm boarding to what? The surface of what? Eaves. And what? Apply 3 coats of what? Gloss paint on what? Eaves boarding. Then you what? Describe. What did we get as our perimeter? 49,500. And then what is the thickness or the distance of our eaves projection? That's from here to here. It is giving us what? 600. So we'll convert it to meters. That's what? 0.60. So doing this, we've measured for our what? Eaves board. So guys, we've come to the end of today's video. Please don't forget to like, share and subscribe to the channel to make this channel grow. Thank you, and we're going to be going to the last episode of the series for measuring members for the hip roof. And in that episode, we are going to be treating the how to measure the roofing sheets and what? The hip and the ridge cap. So thank you, and we'll see you in the next.